Hi, welcome to Shendra's Engineering Tutorials. A topic from control systems which cannot be neglected. Time domain specifications of a second order underdamped system subjected to step input. What's the response? Expression for response U of t equal to 1 minus e raised to minus zeta omega nt upon under root 1 minus zeta square into this one sine omega dt plus, now this is t, okay, this is suffix d and t plus theta, isn't it? For a second order underdamped system subjected step input. Guys, I have linked the proof in the description box, you can find it, and how the response looks like here for different values of t, like t on this side on horizontal axis tending to infinity, and c of t on the vertical axis, and the input being unit step input. Here the output will be commencing from t equal to 0 like this, t equal to 0, it would commence like this, and with a damped oscillations it would settle to the final to the input at t as t tends to infinity. And these are the time domain specifications here. This will be the rise time tr, and the first overshoot, the time at which the first overshoot occurs, that will be the peak time, and this would be as settling time somewhere else here, that will come according to the definition in the ongoing discussion. And these are MP, maximum overshoot. This is our MP, which MP, maximum overshoot. Now what about this one? At t equal to tr, at t, these are the different values of t, isn't it? At t equal to tr, c of t will be equal to 1. That gives the definition for tr from the given expression itself. What is at t equal to tr rise time suffix r, okay, our c of tr will be, now c of t will be equal to 1. That will help us to evaluate the expression for rise time tr. So c of tr, straight away tr will be equal, which is equal to 1 minus e raised to minus zeta omega n tr, wherever we have t, that's plugged in with, upon under root 1 minus zeta square, and even here into sine omega d tr plus theta, isn't it? This is what we have, and which is equal to what? Which is equal to 1 according to the definition, which is equal to 1. Now guys, this one and this one gets cancelled, and we'll be having e raised to minus zeta omega n tr by under root 1 minus zeta square as it is into sine omega d tr plus theta will be equal to 0. Now we have three terms over here, e raised to this one, and this one. This cannot be 0. Why? The reason, e raised to, we are talking about a finite value of time, okay, these are finite, and we are talking about a finite value of time. So this cannot be 0, and we don't have a t term over here. I mean, this can't be 0. This can't be 0. If this is 0, the entire term, that will be infinite, right? So this has to be 0. This should be 0 to make the entire term to be 0. So making that what? Sine omega d tr plus theta, that should be equal to 0. And for what value of sine will be equal to 0? What value over here will give us sine something is equal to 0? It's 0, pi, in multiples of pi, right? 2 pi, 3 pi. So sine pi will be equal to 0, right? So this should be equal to 0. So what is that? Omega d tr plus theta should be equal to pi. And what are we searching for? For tr, right? Rise time tr. We have tr will be equal to pi positive theta, that becomes negative theta, by omega d. This could be substituted with omega n into under root 1 minus zeta square, which we have proved in while deriving this expression, please. And what will be theta over here? Even that can be had, even that zeta square, okay, that got cut. What will be theta? If we could have a, there was a triangle, a right angle triangle with under root 1 minus zeta square and zeta on this side. So if this is the case, this square plus this square, that will be 1. We had a triangle, we made use of this triangle to evaluate this expression. Go back to that one. And theta being here. So in this case, theta will be equal to tan inverse this one, opposite by adjacent, right? Under root 1 minus zeta square by zeta. This will be our theta over here. And so final TR, rise time TR will be equal to pi minus tan inverse, what's that? Under root 1 minus zeta square by zeta here by omega n into under root 1 minus zeta square. Now we have to make use of this expression, the expression for rise time. Make a note, please. How to evaluate for TP? The first derivative of the response subjecting equal to 0, the leftover will be the expression for TP. D by dt of C of t will be equal to, guys, this is 1, so that will be 0. We have two terms over here, so making use of UV rule. Derivative of the first term, it's a minus of e raised to minus zeta omega n t upon under root 1 minus zeta square, and the derivative of the first function. So what we have, it's a minus zeta omega n with respect to t again, right, into the first function as it is, sine omega dt plus, this will be the suffix, okay, omega dt plus theta, and plus the derivative of the second function. This comes as it is, it's a minus e raised to minus zeta omega nt by under root 1 minus zeta square into the derivative of the second function, it's a cos omega dt plus theta into omega d, because we have to obtain the derivative of this one with respect to t, isn't it? So in that case, guys, something could be, now this and this, that becomes positive, this and this becomes positive, taking out e raised to this one, taking out e raised to minus zeta omega nt upon under root 1 minus zeta square is taken out as common, and something else also can be taken out. Guys, a small transition over here, this omega d could be substituted with this one. So in that case, here I'm rewriting over here, omega d could be placed with omega n into under root 1 minus zeta square. Okay, so in that case, omega n also can be taken out as common. Omega n also can be taken out from this and this. So what will be left over if all these are taken out? We'll be having, guys, this is positive, omega n is taken, so we'll be having sine omega d t plus theta into zeta, here this zeta, we didn't take this zeta as common, and here it will be negative, it's a negative because of this negative, and all these are taken out, positive is taken out, isn't it? All these are taken out, so it will be, even omega is taken out, cos omega dt plus theta into under root 1 minus zeta square, right? So guys, this will be omega n into e raised to minus zeta omega n t by under root 1 minus zeta square as it is. This could be simplified to something else, as it's a cos theta from the triangle which we made use of to reduce to this expression. From the triangle, this will be cos theta, in the sense here sine omega dt plus theta into cos theta minus, here it's a cos omega dt plus theta. This will be sin theta from the triangle. This will be sin theta, this one. And can you see sin A cos B minus cos A sin B. Making use of this one, sin A cos B minus cos A sin B. Now the entire expression could be reduced to, here it will be omega n e raised to minus zeta omega nt upon under root 1 minus zeta square as it is. So this will be sin A minus B. So what is A here? It's a omega dt plus theta is our A, minus what's B? It's theta. Here this is the transition, which is equal to 0, and the first derivative when subjected equal to 0, that will give us the peak time, and this t is Tp over here, in this case Tp, and now this will be Tp, which is equal to 0. And here this positive theta, negative theta goes away, and in this expression this cannot be 0. Why? Because e raised to, we are talking about a finite value of time, so this will be finite, and e raised to negative finite, that is not 0, and this is not 0, nothing is 0, this should be 0, in the sense sin omega dTp should be equal to 0. Now this should be equal to pi for that to be 0, right? That is omega dTp should be equal to pi for this to happen. In the sense we are in search of Tp, which is equal to pi by omega d, which is equal to pi by omega n into under root 1 minus zeta square. Expression for the peak time, this one for the peak time. How to evaluate the expression for maximum overshoot? We have a definition for maximum overshoot, that's given by mp is equal to c of Tp minus c of infinity upon c of infinity, and if it's percentage mp into 100 will give us the percentage overshoot. That isn't a big deal. Now what is a c of infinity? It's a 1. As t tends to infinity, c of infinity will be 1. So in that case we have c of Tp, in the sense 1 minus e raised to minus zeta omega n Tp, right? C of Tp upon under root 1 minus zeta square into sine omega d Tp plus theta. This is the case, right? Tp, and minus this one, I'm sorry, we need to go for minus 1 according to the definition. By 1, that's 1, so I'm not considering that one for the time being. If we need percentage overshoot, that's multiplied with 100 at the end. In this case, guys, this gets cancelled here, this positive 1 and negative 1 gets cancelled. We are left with minus of e raised to minus zeta omega n, and this Tp could be substituted with that Tp which we have evaluated just now for the time period Tp, peak time. It's a pi, this is omega n, so we need to substitute this one so that it gets simplified even more. Omega n into under root 1 minus zeta square upon under root 1 minus zeta square as it is, no change in that. Talking about this one, it's a sine. Now omega d Tp could be plugged in with this one, so that this can be even more simplified, pi by omega d plus theta. Yeah, closing the bracket. Now what get cancelled over here, guys? Omega n from here, omega n from here, and omega n from here, omega d from here, and this one gets cancelled, and we are left with, guys, and one more thing, it's a sine pi plus theta, that will be minus sine theta. This one, this sine pi plus theta, that will be minus of sine theta. So we have a negative over here. This negative and this negative becomes positive. So we'll be having e raised to minus zeta pi by under root 1 minus zeta square exponential power. Okay, don't get confused. It may be crooked. Please don't mind. By under root 1 minus zeta square. And we are left with this negative came out, right? And so we have sine theta. Sine theta, right? And guys, one more simplification over here. This sine theta and this sine theta gets cancelled. Why? Because this is equal to sine theta from the triangle. Don't get confused. Which will be equal to e raised to here, e raised to, let it be in black for more clear, e raised to minus of pi zeta by under root 1 minus zeta square. This is the expression for MP into 100 for percentage MP overshoot. Guys, this is the expression. So getting back to the expression for the response of the second order system. Now this exponential is responsible, this term is responsible for damping. Making use of that expression, that term, we can evaluate the expression for TS, the settling time. And it will be asked to evaluate that expression for settling time for a 2% tolerance, 5% tolerance, etc. For 2% tolerance, we have at T equal to Ts. Now this one will be e raised to minus zeta omega n Ts will be equal to 2%, right? We need 0.02. It's 0.2%, 0.02. Now applying the natural log on either side, it's a ln on either side, ln and ln on either side. Guys, this gets cancelled. You can check in your calculator. Ln e raised to 2. Check now. Ln e raised to 2. You will be left with 2. Ln natural logarithm and exponential gets cancelled. Check this one. So we'll be left with minus of zeta omega n Ts, which is equal to, now this will be minus 4. Ln 0.02 will be minus 4, and this gets cancelled. We are in search of settling time Ts, right, which is equal to 4 by zeta omega n. Guys, this is the expression for the settling time Ts, the final one. And the zeta omega n, the product, is known as the time constant. 1 by zeta omega n is the time constant of the second order system which we are talking about. Hope you understood the derivation, all the time domain specific. Very important one for the university exam point of view. Even competitive exams, you'll be asked, evaluate the rise time, evaluate the zeta value, etc., etc. Hope you understood this one. Support me with your valuable share and a subscription if you find it useful. Thank you for watching.